Example 7 says differentiating a quotient with a constant numerator. So this only works when you have a constant numerator, constant being a number. So what's the idea? A lot of students would see this as a quotient rule. A quotient rule, again, you do low, which the low function here would be 2x plus 1. The derivative of the low function would be the derivative of 2x plus 1, which is 2 times 1 plus 0, or just 2. They'd look at the high function at being 4. The derivative of the high function here, the derivative of 4 is 0. And they would use the quotient rule, so they would say the derivative is low d high minus high d low over what's below squared. And this works. This works perfectly fine. But let's look at this. The low function would be 2x plus 1. Derivative of the high function, well, that's 0. Minus the high function, which is 4, times the derivative of the low function, which was a 2. All over the low function squared, which would be 2x plus 1, quantity squared. Look at that first part, that 2x plus 1 times 0. That's 0. 2 times 4, well, that's 8. So cleaning that up, I'd end up with negative 8 all over 2x plus 1, quantity squared. That would be my derivative right there. So that would be using the quotient rule. But I told you, when do I use the quotient rule? Only if I absolutely have to. And this is a case where you technically don't need to use the quotient rule. It only works this way, so nice this way, I guess I should say, if and only if you have a constant on top. So we only have a constant on top. What am I talking about? Well, would you agree that this is really 4 over 2x plus 1 raised to the first power? And technically, if I wanted to, couldn't I write this as 4 times 2x plus 1 quantity raised to the negative first power? Would you agree that that's the same thing? Remember, if you bring something to the top, you just make the the exponent negative. And if I'm doing that, I can use the general power rule. Keep that constant multiple if we want to find y prime. Keep that 4, drop the power. That'd be negative 1 times 2x plus 1. The power minus 1 would be negative 2. And then we have to multiply times the derivative of the inside. Well, remember the derivative of the inside here, the derivative of 2x plus 1 is simply the number 2. So putting this all together, what do we have? Well, 4 times 2 is 8, so we'd have an 8 on top. We also have that negative 1, so that's a negative 8 on top. And then we have 2x plus 1 raised to the negative second power. Again, with a negative exponent, you throw it into the denominator, and you'd have 2x plus 1 squared. So another way that you could solve this problem, if you wanted, is to put it into exponential form, move it into the numerator, find the derivative using the general power rule instead of the quotient rule. If you look, it seems like a lot less work, and it can be a lot less work. Both of them get you the correct answer, and I would accept both of those techniques on the test, so it's totally up to you. All right, so let's go to example 8 here. It says simplifying by factoring out least powers. Find the derivative of y equals x squared times the square root of x squared plus 1. This is more like it. This is a problem that could be on the test, because this is one where we have a product between two things. If you notice that it's the product between x squared and the square root of x plus 1. In fact, let me even emphasize that. This is going to be y equals x squared times x squared plus 1 raised to the 1/2 power. This is a product rule where you have to use the product rule, where you can't just, distribute it out or something like that because it's raised to the 1/2 power. Anytime that power is not 1, you can't just distribute it. So we actually have to use the product rule. So this is the type of problem that I'd put on the test, and I'd say find the derivative of this because I know you have to use the product rule. So let's look at this again. What's our first function? Our first function is x squared. The derivative of the first function would be, well, the derivative of x squared is 2x. The second function is the second one, which is x squared plus 1 raised to the 1/2. And now to find the derivative of the second function, we have to use that general power rule. So we would drop the power, 1/2, keep the inside exactly the same, x squared plus 1 raised to the power minus 1, which would be negative 1/2. Then we have to remember we have to multiply times the derivative of the inside. So x squared plus 1, the derivative of that. Well, the derivative of the inside, x squared plus 1, is 2x plus 0. So it's just 2x. Notice the 2's would simplify. We have a negative exponent of 1/2, so I'm going to throw it into the bottom, making it a positive 1/2. So this is the same thing as x over the square root of x squared plus 1. And again, that top one is the square root of x squared plus 1. So when I look at this, when I find y prime, I know it's 1d2 plus 2d1. The first times the derivative of the second plus the second times the derivative of the first. So let's do our math out here. We have the first times the derivative of the second. So that would be x squared times the derivative of the second, which is x over the square root of x squared plus 1. Plus the second being the square root of x squared plus 1, times the derivative of the first. The derivative of the first was the 2x. This is the one that I just did right there. And we know that it's plus in between them. Okay. So let's see if we can clean this up a little bit. We'd have y prime equals, well, x squared times x is x cubed over the square root of x squared plus 1. Plus, and then we'd have 2x times the square root of x squared plus 1. Well, what's this say? It says we want to factor out least powers. Well, this isn't really fun. They really pull you with factoring stuff out here. And I'm not going to lie, factoring stuff out here really isn't that much fun. What you realize is both of these terms have an x in them. And both of these terms have a square root of x squared plus 1. But the question is what power could we factor it out to? An easier way of doing this power, or this problem, I'm not going to do what they do. I'm actually going to get common denominators. So instead of factoring it out, I'm just going to get them a common denominator together. So what's the second term missing? The second term doesn't have a denominator of the square root of x squared plus 1. So I need to multiply both the top and bottom by the square root of x squared plus 1. So when I do that, let's think about this. Our first term stays exactly the same. So we have, y prime equals x cubed over the square root of x squared plus 1. The second term, let's think about this. It's definitely over the square root of x squared plus 1 now, but let's think about what we're going to have. We might want to do some side math here. So if we take the square root of x squared plus 1 times the square root of x squared plus 1, that's the square root of x squared plus 1 squared, which is just x squared plus 1, right? But then what we want to do is take that 2x and distribute it through. So we're going to do 2x times x squared. 2x times x squared would be 2x cubed. And then we do that 2x times the 1. 2x times 1 would be a plus a 2x. Now we have a common denominator, so I'm going to move up here. Because we have a common denominator, when we add them, the denominators stay the same, and then we just add the numerators. So if we add the numerators, we'd end up with x cubed plus 2x cubed plus 2x. This is all over the square root of x squared plus 1. Combining like terms, we would end up with x cubed plus 2x cubed would be 3x cubed plus 2x all over the square root of x squared plus 1. And there's our final answer right there. As far as they see it, that's our final answer. Technically, it says factoring. So you could see, theoretically, that you could factor out an x in the numerator. If you factored out an x in the numerator, what would have you had? Well, it would have just been x times, 3x cubed divided by x is 3x squared. 2x divided by x would be plus 2. And then this would be over the square root of x squared plus 1. So technically, that's the combined simplified version. I'm not going to lie, though. Where would have I stopped with this problem? I'm going to highlight it all the way back here. Personally, the only reason that I went any further than that purple step right there is because the problem wanted us to simplify it by factoring out the least powers. In other words, it wanted us to combine it into a single term and write it in factored form. I never, ever, ever would have gone past this pink or purplish step right here. I would have left my answer in the form x cubed over the square root of x plus 1 plus 2x times the square root of x squared plus 1. They just wanted you to do that extra algebra and clean up your final answer. I never would have. So just be careful to read the problem. If it said find the derivative and it didn't specifically state which one it was, didn't specifically state that it wanted you to simplify by factoring, then you could have left your answer in the purple form and WebAssign or your computer system would have accepted it, or should have anyways. Moving on to example 9, it says differentiating a quotient raised to a power. Find the derivative of f of x equals x plus 1 over x minus 5 quantity squared. Numerous ways that we could do this problem. Because it's a square and only a square, we could distribute the square to the top and bottom, FOIL them out individually, and then use the quotient rule that way. Perfectly fine, that would work. Not saying that's the best method, because if this were not a square, what if this were a 4th power, 5th power, or even worse, a 45th power? That strategy certainly wouldn't work too well. Could work, but wouldn't work too well. It would take a lot longer. So what are they getting at here? I mean, really what they're talking about here is think about u as the inside, which is that x plus 1 over x minus 5. So again, if I wanted to find the derivative of u with respect to x, u prime, right? I would have to do the low d high minus high d low over what's below squared. Well, in this case, the low is x minus 5. The derivative of the high, the derivative of x plus 1 is just 1, minus the high function, which is x plus 1, times the derivative of the low function. Well, the derivative of x minus 5 is just 1, all over the low function squared. So that's x minus 5 quantity squared, right? Let's keep on going here and continue on. So this would be x minus 5. I'm going to distribute my negative term through. So that's going to be a minus x and a minus 1. And all of this, again, is over x minus 5 quantity squared. Put it together, those x's cancel. So I'm ending up with negative 6 over x minus 5 quantity squared. So that's u prime, right? That's the derivative of the inside, if you will. So why do I care about that? Because if I go back to the original function and I want to find the derivative, what we know it is drop the power, which would be the 2, keep the exact same thing on the inside, x plus 1 over x minus 5, raised to the power minus 1, which would be the derivative, which would be first. Second, minus 2 minus 1 is 1, so that's the first power. But then we need to multiply that times x plus 1 over x minus 5 prime, right? But that's what we just found. That's what we just found right there. We just found the derivative of the inside. So this thing right here is negative 6 over x minus 5 quantity squared. So what I really have is a 2. I have an x plus 1 over x minus 5. And then I have a minus 6 over x minus 5 quantity squared. Let's clean that up a little bit. Negative 6 times 2 would be a negative 12. We still have the x plus 1 on top. And then on bottom we have x minus 5 times x minus 5 squared. So that would be what? X minus 5 quantity cubed. Nothing simplifies, nothing cancels. Looks good to me right there. There's our final answer. Negative 12 over x plus, or negative 12 times the quantity x plus 1, all over x minus 5 quantity squared. Okay, so it's an example, a nice example of the chain rule. Drop the power, same thing, power minus 1, times the derivative of the inside, but the derivative of the inside required that we use the quotient rule. So that's all the stuff that I did in the red. So try to keep all that together, and hopefully that works for you.